Assalamualaikum and good day all. Today, I would like to explain about theoretical of lab 3 about force in rigid body. So in the lab 3, we will cover of learning outcome number 2 and program outcome PO number 4. Okay. This lab, synopsis, this lab activity will enrich students' knowledge on static. Students are exposed to the concept of force in rigid body. So, the related lecturer topic will cover equilibrium of rigid body, free body diagram in 2D, and equations of equilibrium constant for a rigid body. So, before you fill in all the lab sheet, you should be read the instruction first, what the lab sheet need, and then what the lab sheet wants. The first one, instruction, laboratory report should be in English. Submit your report once only in a single file. Submit your report online, and this lab report activity account for 5% of the total marks of the course. Okay. Now, without the waste of time, what you should be fill in the lab sheet, the task should be the fulfill. The first task is find the theories. So what you want to, what we need to complete in this task, the first task is should we cover the normal and friction forces, action and reaction force, equilibrium of rigid body for single member, and how to find the relationship of two data from line graph, and then the last, how to calculate random error and systematic error. Okay, write your related theory here. So what theory should be write down here is about theory of moment, equilibrium. Okay, you should be write down here all theory, and then we go to second task. Task 2, draw the free body diagram. Okay, how to write down the free body diagram should be known first. Which one? The body. Okay. Okay, in this case, the body is rigid body of the beam. By put the weight within the point A and B. So the length of point AB we call S, while the distance within the point A to the wake coordinate or point we call D with the certain angle of theta. Okay, remember, before we draw a BD, you should be recognized which one the body. Okay, in this case, the body is the beam by certain angle of theta. Okay, and then you should be write down all of the forces work on the beam. So the first one, recognize the wake. So this one wake. Okay, but perpendicular from the beam into the wake, yeah, we call cos theta, because the theta is reflect into this coordinate. And then also work here, W, wait, sine theta. So we try to search another force work. Okay, based on the figure, we have also here work B, because in the point B. And also we have also here also A. Okay, back into the point B, the B have the certain of force work, because if we reflect to the beam angle, we have B in the perpendicular perpendicular into the beam. Now we call B in the sine theta. And also here we have a friction work here, to support the beam in certain angle by certain weight here. And also here we have in the Y. And also we can reflect to B, Y. Okay, after finish all of the ABD, we can go. Okay, after we are finished in the task 2 to create the FBD, now in the left sheet we have task 3 to derive the equation force here. So based on your BD above, derive the equation of force in the X and Y direction. Derive the moment equation at the point A. And then the next, based on the 3 equation above, derive the equation of normal force in terms of S distance, D distance within the wake in the point A, mu is the coefficient, friction coefficient, and the theta is angle of the beam or the truss. And then the last, report your data using the table below. Calculate for theta, for all theta in increment order to get normal force values. You may not able to calculate the normal force because mu is not provided. You may assume this value to look at the trend of the data. Okay, based on the FBD, please create here sum based on all of a force. First one, please sum force in the X direction. So equal to 0. So this means in to the right side consider positive, and then you can sum of forces work in the X axis based on the FBD. So calculate sigma fx, sigma fx. So what we have here, based on the FBD, we have F friction in the right is mean positive, and then opposite to B. Yes. B is mean to the left side. So equal to, okay, equal to 0. And then if we want to simplify this equation, yes. So F friction equal to B. And then what else? We try to sum of moment that work in the truss. So we consider counterclockwise is positive. So to be, we try to create of the symbol like this. Then calculate of sigma in the point A. Point A equal to 0. 0 is mean in the equilibrium or static. So sigma moment on A, we can calculate B times to S as total distance or length of truss, and sinus theta negative 2 W, and then time to D, and then cos 2 theta. So because in equilibrium should be in 0. So okay, now we try to understand B time to length, total length, because B is the end of the truss to the point A by total length. Total length, because A and B distance of length of the truss. Sin to theta is mean should be referred to condition of Y. Yeah. Okay. The Y condition should be in the sinus. So why the value is positive? Because we mentioned before here, the symbol show CCW or counterclockwise is positive, and this one is negative. And we can simplify this formula by carrier of F friction equal to WD and S tangent theta. Okay, now we call us equation 2. Okay. After that, because of F friction equal to B, so from the equation 2, we can elaborate of B, simplify the equation B equal to F friction. Okay. Now just simplify the formula F friction equal to mu times to force normal, and then B back into the equation 2. Okay, equation 2. Yeah. put equation 2 here, and then you can find the final formula is n. Please find the n here. After that, now we can go to complete the task 3 from the lab sheet. So based on the table in the task 3, angle varied from 20 degree until to 60 degree. So for the week 1 and week 2, please check the video to complete all table. And then the distance is varied, the distance of week from the distance in the millimeter of 660 until to 375. Okay, please complete based on video. And then for normal force, calculate from the equation what the final of single value if the angle 20 degree with the distance 660. Okay, after finish the task 3, now we go to task 4. Find the relationship between the normal force and inclination angle. By using the calculated data, you can find the relationship between a normal force and an inclination angle. The best way to show this is by using a graph. However, you may use any method. So, for task 4, please use the table. Yeah. So, what the table we recommend by using the program Excel. Yeah. Please fulfill and show the graph here. For that, we go to experimental work. Experimental work, you can see in the part B here, all apparatus and the equipment name already put in this part. Okay. And then the result will show by video. Please complete the task 8 after the experiment data collected. Find the relationship between normal force and inclination angle. By using the data, you can find the relationship between normal force and inclination angle. Yeah, show here. And discuss. So what discussion 1 is, your result is in theoretical experimental data. Describe the relation between theory and experimental. Describe by finding from the task 4 and task 8. Explain what, when, where. And then the second, what do you experience from this lab 4 or lab work? Discussion 2 is asking the question why. Okay, fulfill all the question. And then also by conclusion. Okay, all assessment will put here the end of the lab sheet. So please learn about this assessment criteria. Okay, that's all for the explanation of lab sheet. Thank you.